Guys, the purpose of this video is just to highlight a few things that you may need some deeper explanation for. So we're looking at waves. We're focusing on electromagnetic waves this week. So just remember, waves carry energy and electromagnetic waves do not require particles. And for all waves, the speed at which the wave travels through the medium or through the space or through the material will depend upon the density of that material. For all electromagnetic waves, that speed would be 3 × 10⁸ meters per second if it were traveling through a vacuum or through outer space where there would be 0 particles, 0 medium. Make sure that you understand that all of these different types of waves are part of the electromagnetic wave spectrum. So they're all going to travel at light speed. The purpose of the visual at the top of the slide is to allow you to have something to illustrate how the shape of the wave changes regarding the wavelength and the frequency. So the far left is going to be the longest wavelength, lowest frequency. Far right is the shortest wavelength. Be prepared to answer questions about how the wavelength compares for different types of electromagnetic waves, or within the visible light spectrum. We have the different colors, and so you'll be asked to answer questions about wavelength and frequency, comparing one color to another, but it all follows that same pattern. Some of the wave behaviors that you'll need to know for this unit are diffraction, which is basically where a wave is going to pass through a hole, an opening, a gap, or bends as it goes around a corner or an edge. And with diffraction, we are basically seeing that that wave kind of fans out. And so it's going to cover a larger space, and it's going to cause the shape of the wave itself to change just a little bit. Reflection is where the wave is going to hit some sort of boundary or barrier and bounce back. The most important thing that you probably don't instinctively know is that the angle at which the wave enters that boundary or surface is the same angle that it exits, but that angle is going to be measured from what we call the normal line. And the normal line is going to be a 90-degree perpendicular imaginary line from that boundary. So if this is my normal line, it is drawn at 90 degrees from this reflective boundary, whatever that is, that's the wave is going to bounce off of. And what we're saying with reflection, not only is it in general that the wave bounces off, but more specifically, if we can see what that angle is that the wave comes into that boundary, then it's going to bounce off at exactly the same angle being measured from the normal line, okay? And the other thing that you need to make sure you understand about reflection is that the wave that comes off is identical to the wave that went in. So in other words, it's the same wavelength, same frequency. So nothing about the wave itself has changed. It just simply bounces off. For refraction, this is where we have a wave that's going to pass into a different material. Each material is made of its own arrangement of atoms or molecules, and so different types of materials are going to have different densities. So it's that density that causes the wave to change how it is moving. So when we're talking about refraction, if we have water and there's light that comes in, this would be the air, and this would be water. So if we have a beam of light that comes in, it normally, let's say that it was just passing through air, would follow this path, right? And so that light would end up over here somewhere. But if we are having it go into a different material with a different density, then the, I guess, quote unquote thickness, the density, how crowded it is in that material is going to affect how quickly the wave is able to pass through that particular space or medium. So if we have something like this situation where water is more dense than air, then it's going to cause the light wave to fall short of the path it was originally on because it's now moving through a more dense material. So that's going to cause the wave to slow down or move slower. So once again, our normal line, that perpendicular reference point, is what we would use to help guide us in describing how the wave has been affected. So instead of it reaching farther out to the right, this wave is going to now bend, and it's going to land somewhere shorter or closer to that normal line than what it started if the material that it's passing into is a more dense material. Obviously, if it moves into a less dense material, then the outcome would be reversed. It would bend farther away or have a greater angle away from that normal because it would be moving faster through a less dense material. Okay, and that's what these illustrations were about. Okay, so then let's talk about this vocabulary word here, mirage. So this is a word that you're going to need to know. And what I want to point out to you is that a mirage is an example of refraction. Please make sure that you get that correct in your assignments for this week. So basically what happens in a mirage is the light is going to pass through the air molecules. And in this particular situation, you can see my example here is a road. And so let's just assume that we are in Texas and it's July or August. We know that that road is going to be super, super hot. So what happens is that the molecules on the surface of the road change density from the air farther above the surface. And so whenever the light passes through the air molecules there right at the surface of the road, because that air has a different density, when the light passes through it, the speed is going to be affected because it is now less dense. And as a result of that, the blue light shining down from the sky, rather than passing through and landing somewhere on the road, it actually bends so much that it comes up to our eyes. And so we're actually seeing blue light being bent or refracted through the air molecules down at the ground so much that it's coming up from the ground. All right. If you need a deeper explanation or maybe want to see some more examples, please Google Miss Espinosa Physics and then go to the link on the left side for the chapter that we're in, which is over light. And the top 4 videos that I have on that page are going to be really helpful for this chapter, talking about some of the wave behaviors that I just discussed, as well as some color information. Okay. All right. So that's it for what I wanted to cover today. So I hope this was helpful. Again, make sure that you are looking at the PowerPoints and attempting to get more details from that as well, in addition to watching the other videos that I have on my site. You guys have a great day.